All right, in problem number 2, the Springfield City Pool is 50 meters long and 25 meters wide. The water in the shallow end of the pool is 1 meter deep and runs 25 meters of the length of the pool. Okay, so that's this part over here. And then the depth gradually increases from 1 meter to 3 meters over the middle 14 meters. And then the last 11 meters of the pool is 3 meters deep. And we're asked to find how many cubic meters of water are in the pool. Alright, so we have a little picture here too, which is kind of nice. So let's take a look at this picture. And my hint to you would be to sort of divide this shape up into pieces that are a little more manageable. Okay? So like if you were to break off this part here, and if I draw a line like going back here, you can see that this rectangular prism, essentially, is pretty manageable. It's pretty easy to calculate the volume of that. You know, it's 11 by 3 by 25, right? So you know the length and the height and the width, and you can calculate that. And the same way over here, you can break this up into a big rectangular box, okay? And it's 25 by 25 because the width is 25, so this is 25 as well. And it's 1 meter deep, so that's pretty easy to calculate. And then there's this middle piece here, okay? And another hint I would give you is that it helps to know something about a prism, okay? Because this is essentially a prism. And let me scroll down here and show you some other prisms, okay? So do you see the prism in this swimming pool here? A prism basically has a cross section. Like if I look at this particular triangular prism here, you can see that no matter if I cut it across here, this cross section through here is going to be the same as this end cross section, and it's also going to be the same as this end cross section. So the area of any cross section of this triangular prism is constant, okay? And we call the ends, we call this the base, okay? And then this is basically the height. In this case, when it's laying down, this looks like the length, but it's the height relative to this base. So if it were standing on its end, it would look more like a base, and the height would come up, okay? So do you see the prism in this pool? The prism in this pool, now you gotta look for where you could slice it and all the cross sections would be the same. So actually if I slice this pool across here and down, I can come down, you can see that all the cross sections are going to look like the sides of the pool. Okay, so all those cross sections are going to be the same. So you could treat this like a prism where the side of the pool is the base, and so what's the height? It's actually the width of the pool, right? Because it's the side perpendicular to the base. So the height of the prism is actually the width of the pool. Okay? It's good to be able to turn things around in your mind and see. So this is really a prism. So let's go ahead and solve this problem. So given that this is a prism, what I can do is find the area of the base, which is the side of the pool, and then take it times the height. Okay? And that's a bit easier. So let me change colors here. So here we have this, and we do have to break it up too, because it's a lot easier to calculate. It's really easy to calculate this rectangle here. You know that the area of this rectangle right here, this portion of the base is going to be 33 square meters, because it's 11 times 3, right? 11 by 3 is the area of that piece of the side. And over here, it's not too bad either. We've got this rectangle here, which is a piece of the side. It's 25 by 1, right? Because it's 25 feet this way and one foot high. So it's the area of this rectangle is 25. Okay. So then there's this middle piece. Okay. And you can do this a couple of different ways. You might recognize that this is a trapezoid, okay, because we have two parallel sides. Usually you see a trapezoid drawn like this, where you've got two parallel sides, and so these are parallel, and then the other two sides are not parallel. So here we have two parallel sides and two that aren't parallel. So we can use the formula for the area of a trapezoid to get this area. Or if you prefer, you can actually divide this into a triangle and a rectangle. Okay, so you know that the height of this rectangle is 1 and the length is 14, so this is going to be 14. And we can use the formula 1/2 base times height to get the area of this triangle. So in this case, the base is going to be this. Oops, didn't mean to do that. Oh, let me click on, okay. So the base is going to be this side here, and the base is going to be 3 minus 1, which is 2. So that's 2. And the height in this case is this distance here, the 14 meters. So you get 1/2 times 2 times 14, which is just 14. Okay. And if you did it by the trapezoid method, you know that the area of a trapezoid is equal to 1/2 of the sum of the bases. So this, we call it B1 and B2. So B1 plus B2 times the height, which is the distance here, okay, from the top to between the bases, the distance from between the bases. So you can see here we have one base. Let's just write that out. One base is 1 and the other base is 3, because this is 3 meters deep and this is 1 meter deep, and the height is the distance between the bases, which is 14. And you can see we'll get the same thing if we were to add 14 and 14, we get 28. And so if we would take 3 plus 1 divided by 2, that, and then multiply times 14, we do get 28 for that as well. Okay. So we can add up the areas here. So the area of the base is equal to 33 plus 28 plus 25. Okay? And if you add that up, we get what? We get 86. Okay? So that's square meters. Okay? So that's the area of the base. And then to get the volume, we just multiply by the height, which is the width of the pool. So the volume is equal to 86 times 25. And when you multiply that out, you'll get 22,150 cubic meters. And that is our answer.